Hey, what's up guys? So in this video we're going to be talking about RTCs, or real-time clocks. And I know a lot of you already know quite a bit about RTCs and when and how to use them. You might even have your favorite RTC like I used to, the DS1307. I used to use this on every single project that needed an RTC. But recently I actually found this one, which I think has a lot more features and is actually cheaper. So we'll get into that too. But in case you're not familiar with what an RTC is, basically it's just a chip that keeps the time. RTC, real-time clock. So if you have a project where you need the real time, the real human readable time, this isn't going to keep track of milliseconds or microseconds or anything like that. It's got a resolution of 1 second. So right here I've got actually some demo code running here where the Arduino is communicating to the RTC, reading out the time. And you can see, it's incrementing 1 second at a time. But what's nice about it is that the Arduino can be busy doing its own thing, and then anytime it needs to go read the time, it can just communicate via I2C over to the RTC and read that time out. Now this is actually considered an RTCC because it also has a calendar built in, and this will take care of everything. It's going to automatically increment the minutes, the hours. It knows that it can do 12-hour, 24-hour mode, the day of the week. It's also, as you can see, dealing with the day, month, and year. So it'll handle all of that. It knows how many days are in each month. It'll even keep track of leap year and things like that. So a very useful part for building alarm clocks or time stamping events, or for me what I think is very useful is low power wake up. So like over here on the Arduino, if you wanted to sleep this like in an ultra low power deep sleep state where you only wake up from an interrupt, you can actually communicate over to the RTC, configure its alarm to wake you up in, 5 minutes, and it will do that. And then you can go to sleep. It'll then wake up in 5 minutes and trigger that alarm. You wake up and then do whatever you had to do. And since this part is only keeping time, that's its only job, it can be in a very low power state. I mean, it's a very low current consumption part. So, and it also has a battery backup. So like if you totally lose power from the system, like I'll do right now, it's continuing to keep the time here because it does have a little coin cell battery. And you can see the Arduino over here is kind of freaking out because it's trying to communicate with it. I don't have any checks in here to see whether or not the data is good, but you can see that it's just reading nothing out of it because nothing's hooked up to the RTC there. But I'll go ahead and plug that back in real quick, and you can see that it immediately regains communication, and the time was continuing to tick even without power because of that battery backup there. So anyway, it's a very cool part, and we'll get into it, and I'll show you how to read the time out, set the time, and even set the alarms. So that's what I'm going to do in this video. But first, let's talk a little bit about the hardware here. So this is the RTC board that I designed, and I'm going to try to put this part just on a breadboard and see how well it can keep track of time. Let me pull up the part here real quick. So here it is, the through-hole version, and you can see it's very low cost. You can get it for 82 cents. So it's very low cost, and if I jump over to my wiki here for that board, RTC board, you can see I've got a schematic here showing the hookups to it, and I may try to actually hook all of this up on a breadboard. Now my only concern here is that the 32.768 kilohertz crystal here, I'm afraid that the capacitance of the breadboard would have a pretty dramatic effect on that and affect the timekeeping of it. So I'm not sure how well that's going to work out, but what I'm planning on doing in a future video is setting up a whole bunch of different RTC configurations here on the bench and letting them just run for a month, and then seeing how well they each keep that time. I'll have a known good timekeeping device like a stopwatch or something like that, and I'll test it out. And in fact, I'll even use the Arduino itself to keep time. So no RTC, just use like Millis to automatically increment the seconds, and then we'll just see how well that was able to keep the time. So anyway, that's for a future video. But in this video, we're just going to go over the MCP7940 here, and I'll show you the code here for it. Okay, so one of the things I forgot to mention was exactly how the connections are made between the RTC and the Arduino. So if we go over to the RTC board real quick here, we do have the two I2C data and clock lines here, and those do require pull-up resistors. So on the board, I forgot to show you that, but I have a 10K pull-up on each of these pins to 3.3 volts, okay? One resistor on each line. Okay, so if I jump back over now to the 328 board here, this is the Arduino platform I'm using, and you see over here analog pin 4 and 5. Those two pins are used for the I2C bus. So you just tie your data, your SDA line from the RTC to the SDA line over here, and same thing for the SCL pin. So pretty easy to set that up, and that's all I wanted to mention real quick there. So over on the data sheet here, again, we're using the N version of the part with the battery backed up clock, and there's all kinds of useful information in here. A couple interesting things that I forgot to mention is that this also supports power fail timestamping. So like, when I ripped the board out of the breadboard there, it actually detected that, and it was able to write a timestamp in memory that we can now go back in and read. So like in your Arduino, when you power back up, the first thing you could do is go and check the RTC and say, oh, what time did we lose power? So that's kind of a useful feature. Of course, we can run down to 3.3 volts. And here are the current consumption specs. So this is pretty cool. 1.2 microamps at 3.3 volts. 925 nanoamps at 3 volts. So extremely low power. And if we keep going down here, here's a nice diagram showing those pull-up resistors. You also need one if you're going to use the multi-purpose function pin. I have a 10K pull-up on that as well for triggering the alarm into the Arduino. I suppose you could just use the internal pull-up on the Arduino. That would probably work for that. So anyway, if we jump down, the first thing I want to get into is the device address. So if we go all the way down here, you'll see this chart here, which is very useful. And this is your first byte. This is the device address, and you can see it's a 7-bit address, like most I2C devices. The last bit's used for the direction, your read-write. And you can see here we've got 1101 followed by 3 ones. And then in the sample code I've written here, you can see right at the top here all my pound defines, the RTC address. And I just popped that right in from the data sheet. Okay, so I want to show you what I've done here first before going through the code. So right over here, we're going to display the time once a second. So I'll show you how to do that. But showing the time is not very useful if you can't change the time. So I've got a little cheat sheet right up here at the top. And if you copy this over for setting, if you copy this right over here into the serial monitor window here, make sure you've got new line here selected. We can set the time. So we're going to start with a T, and then the hour we'll set for 6 minutes. I'm going to set for 40 because it's going to switch here soon. Seconds to 00. Make sure that you have it exactly like this. So if it is 6, put 06. Okay, it needs to be this exact length here, and we'll talk about that later on. But anyway, just wanted to mention that real quick. And then this AB here is to set the 12-hour mode, which we do want. So I'll set that to 1. And then whether or not it's AM or PM, and if it's PM, we set the next character there to 1. And then we have the month, which is 02, day 09, year 17, and then day of the week, which is really kind of doesn't matter, but we're going to, it's a value from 1 to 7, and it's used for keeping track Sunday, Monday, Tuesday, Wednesday, whatever you want. And I've got an array set up here, so 1, 2, 3, 4, 5 is Thursday. So we'll put a 5 in there and then hit enter. And you can see, there you go, change the time. So I'll show you how to do that. I also have the same thing down here for setting the alarm. I don't know if I'm going to get to that in this video because it's going to get a little long, but I have the functionality built in here, the code. So it's the same kind of thing. You've got your hours, minutes, seconds, the alarm mask you can put in, the AM, PM, month, day, and day of the week. So you can set all of that up. And the mask basically sets up what you want to trigger on, what you want to alarm on. Do you want to alarm on a seconds match, a minutes match, hours match, day of the week match, month, day, or all of it? You can actually do it that way. So you've got some flexibility there. The alarm, I will say right now, is kind of finicky. So if you do get a trigger on alarm, you want to go in and make sure that it truly was a real alarm. So just keep that in mind, and I'll bring that up to when I get to that part of it. But the alarm works fine. It's just that you might get a false trigger. And I have that built into the code here too, so you'll see that down there when we get to it. Okay, so that's what I'm going to show you how to do in this code here. So the most useful page in this data sheet is the register map right here. So when you look at this at first, you're like, oh my God, there's like a million registers. You know, this part looks really hard to work with. But really, if you're just keeping track of time, you're only going to use the first 3 registers. If you want the date in there too, you're going to use the next, I don't know, 4 registers there. Everything else is for trimming out the part. You can actually trim the error out of it, or for setting the alarms. Oh, and down here are your power fail and power up timestamps. So really, kind of depending on what you need out of the part, you only have to use what you need. So that's good to know. So let me move that over to the side there, and you can see what I did here is I just pound defined every single register you see here. So like, it just makes it a little bit easier to write the code instead of going back here and putting in okay, we're going to write to 08 register. It's a little bit easier if we've got them all pound defined here. And we could have even taken this a step further and pound defined all of the individual bits as well. And you're going to notice that I just put everything in one tab here. I find that it's a little bit easier in these videos just to do it that way, so that it's just one single file that you can go and chop up and take what you need out of, rather than having a whole bunch of tabs here, even though that does help it keep it a little bit more organized. But since this is just sample code, you know, just one file should be good enough. Okay, so anyway, there's all your pound defines, there's the variables. We'll get into some of that stuff later on. There's the setup, 9600 for the serial monitor. There's the interrupt pin setup for alarming. And then we go and initialize the RTC, which is right here. We're going to run it a little bit slower. We're going to use, by the way, we're using the standard wire library that comes with the Arduino IDE. So you don't have to go and find, you know, any third-party I2C libraries. We're using the built-in wire library. And we're going to set that to 100 kilohertz. So we're going to run a little bit slower because we really don't need it any faster than that for this. And then go ahead and kick things off, wire.begin. And the first thing we want to do is clear out the control register, which is right here. And the reason I'm clearing that out is just to make sure that that MFP pin is not outputting a square wave or anything like that, which you can do. So I'm just turning all of that off. We're using the internal loss, or the, actually if we go down here, might be easier if I go to that part in the data sheet here real quick. And just quick search for it. Oh man, it started right at the beginning. Okay, right. Oh, come on. There we go. Okay, so you can see here that starting right at the bottom, square wave out, you know, who cares? We're not going to actually use it, so we're actually disabling it to 0. All the alarms are disabled. Okay, so I had to look that up. So anyway, for some reason I got hosed up here, but if you wanted to, you can feed this by an external oscillator input, not the crystal. Okay, so anyway, I disabled that to 0. Disabled the square wave, and then we're going to use a 0 for the output of the MFP because we want that to be a logic level low, so a falling edge on that. So anyway, just real quick there, so I didn't have to explain it. Wanted to show you that. And then I'm going to go back down now to the register map right here. Okay, so the first thing we do is clear that out. And here's how you communicate with the device. So wire.begin transmission with the device address. And we're going to write to the this register, control register. So that's the next thing you write out. Then you write the data you want written to that register. And then we're done, wire.end transmission. So that's how easy it is to write to the individual registers. Now the next thing we need to do is flip a bit in the weekday register. And what we want to do here is enable battery backup. Now we could write to it, directly, but what I wanted to do here is, what if there's some data set already in some of these registers here? There may not be, it might be totally fine. But what I wanted to do is first read it out and then flip just this bit and then write it back in. Okay, so that's what I did here. So again, start the transmission with that device address at this register address, weekday. Stop the transmission, and now we're going to request from the device 1 byte. And since our last communication with it was at the weekday address, it's going to read out the data at that address. Okay, so we read it out, give it a little bit of a delay there. I usually just put 1 millisecond delay after doing a request. We could also do some checking here. We could do like if wire.available or something like that. But I find that just a quick little 1 millisecond delay there is all that's needed. Okay, so we read that out here, and then we're going to or equal it with a 08. Okay, so that is going to flip only the bit in that position, 1, 2, 4, 8, right there. So if it was a 0, it's now a 1. If it was a 1, well, it's still going to be a 1. Okay, then we go ahead and begin transmission back with the device, write to that address location, and then we write the data back in. So that's what all that did. Okay, so I do that a lot in this code, so that's why I just wanted to explain how that works, because, well, look at this. The next thing I do is that same thing, but now with the data in the seconds register. So again, we write to it, we request 1 byte from it. Here's that byte. This time we're going to or equal it with an 80, 1, 2, 4, 8, and that is the ST bit, which is the start bit. So we have to set that to 1 to actually start the RTC. And this is one of those gotchas with this part. Like if you didn't flip that bit to a 1, it'll never start. It'll never start keeping time. So you actually have to kind of start it up. Okay, so that's how we initialize the RTC, and then we jump into the loop. And you can see the loop is pretty straightforward. I mean, we go and get the time, we check the serial port, so this is where you would set the time if there was data there, and check the alarm. So if the interrupt triggered and set the flag, we could go and check to see if that flag was thrown and whether or not it was a true alarm or not. And then delay for 1 second, because we really only need to check this once a second. Okay, so I'm going to jump into the get time, and you're going to see this is very easy. So again, start transmission there. We're going to write to the first address there, 00, because that's where we want to start reading from. Stop our transmission, and then request 7 bytes from there, from starting at 0 there. A little bit of a delay, and then read them all out. Now you're going to see what I did here is, as I was reading them out, I was ANDing them with different values, and you can see here like 7F. The reason I'm ANDing it with 7F is because for the seconds, I really only care about the bottom bits here, not the ST. So obviously I want the bottom 4, so that's the F, and then the 7 just for the top 3 bits here. And I do that all the way down through here because, I don't know what's in these gray areas here, so might as well just strip that stuff out. And by ANDing it with that, anything that's a 0 in here would come back as a 0 as well. So that's how I'm able to strip that stuff out. Okay, so then the next thing we do once we get all the data out is we actually have to format it into a decimal number. So when you get it here, it's not going to come at you like just, value 59. You're not going to get 59. You're going to get the ones digit. So if it was 59, this part here would be the 9, and then this part here would be the 5. So that's why we have to take the seconds, first and it with a 0F. This would be the ones. So we're stripping off all the top bits out of it. And then we're adding that to the RTC seconds byte. Shift it over 4 positions. So it takes these 3 bits, shifts them all the way over 3 positions right here, and then multiplying it by 10. Okay, so what that's doing for us is, that's taking the 5 then and multiplying it by 10. So you get the 50 plus 9, so you get your 59. And I'm doing that for the minutes as well. And then when you get to the hours, you've got some other data in here. You've got your 12 and 24-hour mode right there. So, if you had it in 12-hour mode, that would be a 1 there. And then obviously AM and PM right here if you were in 12-hour mode. So a 1 would be a PM there. If you were in 24-hour mode, you need this bit here for if you had a value, if your time was 23. So you would need that bit because, again, this is your 10s. These 4 bits are for your 1s position. So I've got some logic in here to check that. So it shifts over that RTC hours all the way 6 positions over to first check to see if it is in 12-hour mode right here. And if it is, set that to true, otherwise false. And then if it is in 12-hour mode, we've got to format all the time up for that. So first check to see if it's PM or AM, and depending on whether or not it is, we print out, when we get down to it, you'll see here AM and PM down there. And then we actually format the hours here. Okay, and we've got some anding going on in here because now we have to actually strip, let me get to it right here. So we have to strip off some of this other crap that we don't need. So if we just do it real quick here, you'll see shift it over 4 positions there, and it with just a 1 because we're in 12-hour mode and we only need just this bit right here, and then add that to the bottom 4 bits. Otherwise, if it's in 12-hour mode, same kind of thing, except now we and it with 3 because we will need that second 10s bit right there. Okay, I know that's a lot, and I hope that's somewhat easy to understand. The next thing here is the weekday, and again, there's more data in the weekday register. You've got your battery enabled bit, you've got the power fail bit, and this is set if there was a power fail. And then you've got your oscillator running bit, so you'd want to check that to see if the thing's running or not. And that's what I'm doing here, is just checking all of that stuff, setting up these booleans, and then actually setting the weekday. And again, this is a value just from 1 to 7. Okay, and then we go on through, set the day up. I'm not going to go through all this because it's very repetitive. Month, year, and then print it all out. And then based on whether or not it's in 12-hour mode or not, we print the AM, PM, or 24-hour mode. And then print the weekday, month, day, year. Okay, so it's actually taking whatever the RTC weekday was, which was a value from 1 to 7, subtracting 1 from it, because that's what's in my weekdays array up here. Okay, because if I had a value of 1 in there, I'd want to subtract 1, so it would be starting at 0, which would be Sunday right there. All right. Okay, print it all out, print the date, and then we get into the tricky part now, which is setting the time. Okay, so we have this function here, the check serial here, which we're pulling from the loop here. And if I go right here, check serial, and basically this is just for setting the time and alarm as well. And down here we have that. We have our own variables in this function here, And basically, if something is available, we go out and we store everything in this string here from serial. And again, this is sample scratch code, okay? Feel free to completely change this. The idea here in this video is to show you how to change the time, not the method for changing the time, meaning like, you may not want to change the time using serial input. Maybe you want to have knobs or buttons or whatever, you want to use. So anyway, don't get hung up in all the serial stuff here that's going on. But anyway, we've got the string here, and this is the format that it has to be coming in. So it's a fixed format, and it changes everything at once. So if you only wanted to change like the minutes, you can do that. That's easy to do. And I mean, you can basically take what I've done here in this code and do that. But for this example here, I'm changing everything at once. Okay, so if something's available, we read until we get a new line feed, and we store it all in from serial, and then just echo it right back out to you so you can see what you did. And then if that first byte is equal to t, then, which is what it should be, and the length is equal to 23 bytes, which it must be, then you've got the correct length. So like if you screwed this up and only had 22 bytes or whatever, I don't want this going through and you don't want it configuring things down on the RTC with garbage data or data that's not there, right? So anyway, if it passes those check, it goes into here, and now it's actually going to read out the individual characters from that string. So yeah, I know it's kind of a crude way of doing it, but what we're doing here is actually converting the ASCII characters into decimal numbers. So that's why we're subtracting everything from 48 there. And if I just do a quick ASCII table there, you'll see that if we go to like a 1 or a 0 right here, you'll see 48. It's equal to 48 decimal. So if we get a 9 coming in and we subtract 48 from it, we can get the decimal 9 value. Okay, so that's why everything you see here is we subtract 48 from it. So let me get back to I lost my data sheet. There we go. Okay. Okay, so yeah, so if we want to grab the hours, since that's the first thing that comes in, you see, from serial 1 to 2, we first convert them into the decimal number. And since everything has to go into the RTC split up in tens and ones, we have to get the top 4 bits need to be for the tens place, which coming into us, this already would be the tens position. So that's pretty easy. So we shift it over to the left 4 places. And it with an F0 just so it is just the top 4 bits. And then we add that to the ones digit, which is the next one over here, and do the same thing. Same thing for the minutes and the seconds and the 12-hour mode, which is just that A right here. And and if you wanted to use 24-hour mode, you just set that to a 0. And then RTC new hour. So the mode is there, but what I'm actually doing, well, this was kind of an afterthought, but what I'm doing here is now setting the hours. So I'm actually just shifting this value here up to that position in the hours register, okay? And then we do the same thing even with the PM AM setting there. So that shifts over as well. And you can see that or equal. So because since we set it or equal here to the 6th place for the 12-hour mode, we're doing the same thing now at the 5th position for the AM PM setting. Okay, and you see we do the same thing with the months, days, years, weekday, but of course I'm ORing it with a 1 shifted over to the 3rd position so that I keep the backup battery enabled. Okay, then to change the time now we have the values. These are all the values we can shift over, those 7 values that can go over. We first begin transmission with that device address. Let me get the register map over here. real quick. Okay, right here. I just wanted to have that handy. Okay, so we start at the very top, the seconds register there. And what we're doing here is setting that to a 0, the whole register here. And what I'm doing there is setting the start bit here to a 0, which would stop the clock. Now, if you look at the data sheet, you'll see that they've got some app notes in there that you should stop the clock before you change the time, so that there's no, strange rollovers. Like if you're writing the time as it's counting, and it just so happens to be changing over from AM to PM or whatever, you can get some weird glitching. So it's best to stop the clock altogether and then set the time. So what I'm actually doing here is that stopping the clock. So I'm writing a 0, stopping the transmission, and then I'm going and getting the time. Now I'm not actually getting the time. I'm just doing that because when I get the time, I'm setting the booleans down here in the weekday, so that oscillator running bit is set right here. So that's the whole purpose. I could just go grab just that bit right here, but I figure, well, since I've already got the code, I'll just do it there. So it'll go and get the time, and then if the RTC is not running, that should be false, we're good. And that's why when you saw me change the time, you saw it print out RTC has stopped changing time. And then now we're ready to actually write the time. So you see begin transmission with the device, the starting address, which is the seconds register, and then bam, just write down 7 bytes, all written, and the transmission. And then now we're ready to start the device back up. But first we have to read the seconds back out. So you can see we do the request from 1 byte, read it out, or it with that 1 right here, and then write that back in, and then we're done. Okay, and then we set the time. So the same kind of thing happens here with the alarms. And again, I think I'm going to save that for another video. But you just start it with the same thing, A0, the length has to match, and then here's your little cheat sheet here, and I have the mask values down here, and it's doing the same thing. Now, the only weird thing with the alarms, by the way, here's the check alarm function right here. So, it's going, and if it was triggered, it clears the trigger, and then it goes and re-enables the alarm. Okay. And then checks to make sure that that alarm was triggered. So there's a little bit more to it. But the weird thing with the alarms is that, if you're going to set an alarm, like you want the alarm to go off every day at the same time, you can do that. It's just that you have to put the exact date in if you wanted it to do that. Like you can't just say every day I want it to go off at this time. You have to set the actually okay, here it is. So in the data sheet, they've got a pretty good write-up here explaining how the alarms work. But, when you set the mask up like this, it's going to alarm every time the seconds match. Okay? And when you do get an alarm, you have to go in and clear the alarm. So, like, if you did do a seconds match, you would have to wait for the following second before you could clear it, because if you cleared it right away, well, it would be an immediate match again. So that's one of the things about the alarms that is kind of annoying to deal with. The other thing too, like I was saying, is that if you wanted the alarm to go off tomorrow every day at the same time, there's no way of doing that, because you've got to match on minutes, hours, days of the week, date, reserved, who knows what's in there. And then seconds, minutes, hours of the day. This one would have been cool, except they added in the day of the week, date, and month. So this could potentially do that, except that every day you would have to advance the alarm registers by the day of the week, date, and month. So you'd have to keep track of that stuff, so that, if I wanted the alarm to go off tomorrow, I'd have to advance all of those things in the alarm register. Or, of course, you could say, well, I want to do alarm 1, I want to do a match on hours. Alarm 2, I want to do a match on minutes. So you could do something like that if you wanted to. But again, for me, I think really the alarms are going to be best suited for low power wake up, so deep sleep wake up. But anyway, we'll talk more about those alarms in a future video because I plan on really getting into that. So anyway, that is the video. I think that covers everything I've got in this code. And again, everything will be available in the description below. So hopefully that helps. Thanks for watching.